Hello everyone, my name is Catarina Reis and I'm here to speak to you a little bit about test design techniques. This is the course of design and testing of software. First, I would like to make a disclaimer that all the content available in the following slides are actually gathered and collected from the official materials for the ISTQB foundation level courses. This is one of the organizations worldwide recognized as an official certification authority for testing of software. What is the actual purpose of a test design technique? Actually, the idea is to help someone that has to make test cases to find those test cases and the test conditions that are required. There are two types of techniques. One is recognized as black box technique and the other one is recognized as white box technique. The color only refers to the fact that one of the type of techniques uses the system as a box where you cannot see through it because it's black, it's opaque, and the other one is a white box technique where you can actually see the transparency and you can actually look at all the code that was written in your products of software. Some techniques are clearly either black or white box, but as seldom happens, others have elements of more than one category and they are considered as gray box techniques. If you look at white box techniques, they are also known as structure-based techniques, while black box techniques are known as specification-based techniques. Let's take a look at what black box means and what are the techniques used for black box testing. So these specification-based techniques usually are a way to derive and select test conditions, test cases, and even some test data that is based on an analysis of the documentation that exists for your software product. Basically, you look at the requirement selection that you have already conducted, and it's possible to infer what are the test cases or the major test cases that your software product should be able to provide an adequate answer to. Remember that when conducting this type of technique, you are considering both functional and non-functional testing. So the idea is to exercise all the features of the software product, but also to take a deep look at non-functional requirements. For instance, one of the most common quality attribute that is directly related to non-functional requirements is the performance considerations. So, for instance, you can collect a functional requirement. For instance, a feature must comply and must present to the user with an answer, must provide an answer to the user, presenting, for instance, a shape on screen or after the user interacts with the menu. All that, the reaction of the system is well known. And the non-functional requirement that relates to performance that usually is mapped to this function, to this feature, is the fact that, for instance, you are, as a user, you are expecting the reaction of the system to occur within no more than 3 seconds. For instance, you, as a user, are not expecting to take 1 hour before the system reacts to your request. And this is one of the examples of non-functional testing that is usually considered or should be considered when trying to design all the test cases, test conditions, and test data. Black box testing, by definition, does not use any information regarding the internal structure of the component or system to be tested. You have data input, you have that data being submitted to the system that is a black box. You don't have to know what's inside of that box, okay? You just input some data and then you are expecting some results. And the results that you are expecting sometimes are equal to the actual results that you get when you submit the data to the system. When that happens, it means that your test, you have submitted the system to a test, and that implies that the test has passed. If the actual result isn't equal to the expected result, then the test will fail. This is good either way, because when they are the same and the test passes, you get to know that your system is functioning according to what is expected, okay? And then you have a test scenario when you can actually say that you validate the feature. When the actual result isn't equal to the expected result and the test fails, this is also good because you have shown where there is an issue, where is a bug, where is a defect of your system, okay? These are some of the most common techniques and the ones that are presented by the certification syllabus of ISTQB. We will speak in detail with the two first ones, so we will be speaking a little bit about equivalence partitioning and boundary value analysis, basically because there are several applications for these techniques and they work hand in hand. Okay, they are complementary to one another. Then we have the decision tables, the state transition, and we have the use cases. Decision tables are quite common to address particularly complex systems, such as systems that are made to help in the decision process. Those are called the expert systems, where you have a lot of variables and you have a lot of rules implemented, and you have to accommodate a lot of internal organization, because the output and the expected output of a system is quite complex, is not linear. So the idea is to use decision tables to accommodate. They actually look like spreadsheets where you have a lot of columns and a lot of lines, where you actually accommodate all the variables that are inside of your system, and it's possible to test every potential result of your system. When we're talking about state transition techniques, the idea is to accommodate systems that actually have several states. They have a built-in state machine, and the system passes from one state to another. This is quite common when conducting software products, okay? You have a system that is in a state, and then you do some action that puts the system in another state. And when this is well documented and the actual state is a part of the life of the software product, you actually have to test each state separately, but you also have to push the system and you have to exercise the system in order to comply with every state transition that might occur within the known states of your system. Finally, we have the use case technique. And the use case technique is the first approach that I believe that everyone follows. Use cases are known to elicit requirements. So in use cases, you have all the features that are expected your system to comply to elicited and described in a rather technical way. So you actually have in each use cases, you have the normal path of the use case where you actually state what your user is doing and interacting with your system, and then you have stated also the reaction of your system. So they are basically a very straightforward advance for establishing your test cases, because all the features are well described in use cases, okay? This means that equivalence partitioning and boundary value analysis are some of the techniques that we will speak in a while.